Okay, let's unpack this. Every single second you're online, there's this kind of silent negotiation happening with your data. We're going to peel back the curtain today on, well, really the engine room of the internet. We're focusing on TCP/IP. These are the absolute core rules deciding if your data shows up perfectly or, just super fast.
That's exactly right. And TCP/IP, it's not just one thing. It's more like a family of rules, protocols. Our mission today is to dig into that fundamental choice, the one every internet thing faces. Do you need perfect guaranteed delivery, or is it all about pure instant speed?
And that choice, it's mostly handled by these two big players in the TCP/IP world, TCP and UDP. We should mention IP, the Internet Protocol, that's kind of the mail carrier, right? Handles addresses, routing.
Yeah, IP gets in the right neighborhood, but
Yeah.
TCP and UDP, they're like the quality control managers working at what we call the transport layer.
Okay, so let's start with TCP, the reliable one.
Right, TCP, the reliable architect. I sometimes think of it like registered mail. It stands for Transmission Control Protocol. Its whole purpose is making absolutely sure data arrives complete in the right order and without errors. It really demands perfection, and it has this meticulous way of guaranteeing it.
And that's the famous three-way handshake, isn't it?
Yeah.
We hear these terms SYN, SYN, ACK, ACK. But why three steps? Like, why not just two to say hello?
Well, it's about more than just saying hello. It's about deep synchronization.
Yeah.
So the first step, SYN, that's the client basically asking, can we talk? But the server replies with SYN ACK. That's acknowledging the request, and it's sending its own synchronization request back.
Ah, okay. So it's confirming I heard you, but also setting the rules for the chat. Confirming starting numbers for data packets going both ways.
Precisely. Then the client sends that final ACK to confirm those terms are agreed upon. Without all three steps, locking down the sequence numbers and stuff, things like web browsing or email or a really important file transfer, they'd be a mess. Data loss, garbled info. TCP is absolutely essential when you just cannot afford to lose a single bit of data.
Okay, for three steps, acknowledgments.
Yeah.
That sounds like it takes time. If reliability is TCP's superpower, what happens when speed, like raw speed, is the only thing that matters?
And that's where UDP comes in, the speedy messenger, user datagram protocol. So unlike TCP, UDP is connectionless. Think of it like sending a postcard. You write the address, you drop it in the mail, and you just kind of hope it gets there. There's no handshake, no did you get it? If a piece gets lost, UDP doesn't really care. It just keeps sending the next piece.
That sounds a bit chaotic.
Yeah.
But I can see where it's useful. Like if I'm playing an online game, right? A tiny bit of lag, because TCP is fussing over a lost packet, is way worse than just missing one single frame of animation.
Exactly. That slight data loss in streaming video or music or voice over IP calls, it's usually fine. The application can often just smooth over the tiny gap. And actually, one of the biggest users of UDP is DNS lookups. When you type a website name, you need that IP address back like instantly. UDP goes for flow over confirmation every time.
Okay, so we get the trade-off for carrying the data itself, reliability versus speed. But how does the network kind of check on itself? Like when things go wrong? That brings us to ICMP, right? The network administrator.
Right. ICMP. Internet Control Message Protocol. This one sits down at the internet layer with IP, and its job is purely diagnostics and reporting. It doesn't carry your web data or emails. It carries error messages. It's the thing that sends back those useful or sometimes frustrating messages like host unreachable or time exceeded.
And that's what's happening when tech support tells you to ping something, right?
Yeah.
You're using ICMP just to see if a server is even awake and responding.
Correct. Just a simple reachability test. But what's kind of interesting is how this diagnostic tool can actually be, well, weaponized. ICMP is often filtered or blocked by firewalls because if someone just bombards a server with tons and tons of these ICMP messages, like an ICMP flood, they can overwhelm it, use up all its resources. That's a type of denial of service attack.
Wow, okay. So putting it all together then, for you, the listener, you're constantly benefiting from this whole setup. TCP is there making sure the important stuff arrives perfectly.
While UDP is making sure your stream or game feels immediate and fast.
And then ICMP is working in the background, handling the essential network checkups and troubleshooting.
I think the biggest takeaway here is that every single thing you do online, from watching a movie to just searching for something, it's defined by that fundamental engineering choice, reliability or speed. You're navigating that trade-off constantly, even if you don't realize it.
It really is this hidden language that just runs everything. So if you found this deep dive into networking protocols interesting, and maybe you want to understand more about how this digital world actually works under the hood, well, be sure to subscribe to the deep dive. We'll keep bringing you more quick, insightful summaries on complex topics just like this one.